Welcome to another deep dive.
Yeah.
Today we're going to be diving into Terraform,
Okay.
but we're going a little bit beyond the basics, I would say.
Right.
We've got some excerpts from a document called Terraform Interview Questions 2125.
Interview questions.
Yeah,
Cool.
which I thought would be interesting kind of as a springboard to talk about some of these concepts.
Yeah, that sounds great. Like
Yeah.
how to use this information to solve real problems.
Yeah,
Yeah.
awesome. So it's almost like we're giving people a cheat sheet for a Terraform job interview.
Uh-huh. I like it.
But the real value is kind of like the insights that we glean from these kind of tougher Terraform questions.
Absolutely. These are
Yeah.
the things that really trip people up in interviews.
Yeah.
And understanding them can take your Terraform skills to the next level.
Yeah, and even if you're not interviewing, like just thinking about these concepts helps you to use the tool better.
For sure. It's like anything else. The more you understand the underlying principles, the more effectively you can use it.
Exactly. So we're talking about things like, drift, state management,
Oh, yeah.
even those like circular dependencies.
Ooh, those can be nasty.
Yeah.
I'll definitely have to dive into
Yeah.
those.
But before we get into like the really tricky stuff,
Okay.
I'm curious about something that seems kind of fundamental to Terraform, and that's outputs.
Right.
Outputs. What's the big deal?
Outputs, yeah, they're super important. Like, what happens after Terraform deploys your infrastructure?
Okay.
Right. You need a way to talk to those things, to get information from them. Outputs are how you do that.
Okay. So it's not enough for Terraform to just like build things. We need a way to get information about those things afterward.
Absolutely. Think of it this way. You just spun up a new server in the cloud.
Yeah.
You need that server's IP address so other parts of your system can talk to it.
Right.
That's what outputs are for.
Okay. So it's kind of like creating a little like directory of important information.
Exactly. A directory you can look up later. Let's say you define an output called serverip, right? Now you can use that output anywhere you need it. Other Terraform code, external scripts, you name it.
And I imagine this gets even more important when you start using modules, right?
Right. Modules are those reusable chunks of Terraform code that we all love.
Yeah. Makes everything more organized.
Exactly. And you can define outputs within modules too.
Makes sense. Outputs help us stay organized.
Totally. But staying organized is just the beginning. We also need to talk about drift.
Oh, drift. That sounds bad.
It can be. It's this kind of hidden danger in managing infrastructure.
What do you mean by hidden?
It's not always obvious that it's happening, but basically drift is when what you think you have, in your Terraform configuration doesn't match what's actually running in the cloud.
Oh, I see. So things are changing without us knowing.
Right. Someone could go into the cloud console and make a manual change.
Yeah.
Or another tool could modify a resource without going through Terraform.
Oh, wow. So like our infrastructure is sort of like secretly changing without us knowing.
Yeah, and that can be a big problem, especially as your infrastructure gets more complex.
Definitely. So how do we deal with drift?
Terraform gives us some powerful tools. The Terraform plan command, for example.
Okay. I've used Terraform plan.
Yeah, you know how it compares your config to what's actually out there?
Right. And it shows you what would change if you applied the plan.
Exactly. So it's like an early warning system for drift.
It's like before we make any changes, we can see if we're about to make the drift even worse.
Exactly. And then if you want to fix the drift and bring everything back into line, you use Terraform apply.
Okay, so it's like having a self-healing infrastructure. You describe the desired state in your code, and Terraform helps you get there and stay there.
Exactly. Terraform is all about that desired state. But to do that, it needs to remember what's already been done.
Which is where the Terraform state comes in.
You got it. The state file. It's Terraform's memory. A snapshot of your infrastructure as Terraform sees it.
So kind of like the brain of the operation.
Yeah, good analogy. And without that state file, Terraform is basically lost. It can't manage anything effectively.
It's like when you accidentally delete a file on your computer and suddenly a program stops working. That file had important information that the program needed.
Exactly. That's why managing the state file is so crucial.
What kind of things can we do with the state file?
Well, there's the Terraform state command, which has a bunch of subcommands. You could list resources, show details about specific resources, even move or remove
It
resources.
sounds powerful. And potentially dangerous if you're not careful.
You're right. Mishandling a state file can cause serious problems. You have to treat it with care. And security is a big concern.
Especially if it contains, like, sensitive information about our infrastructure.
Absolutely. You wouldn't want that falling into the wrong hands.
Okay, so we've got this powerful tool, Terraform, and it relies on this critical state file to keep track of everything. But what happens when things change? I mean, tools evolve, cloud providers update their services, we're constantly learning new things. How does Terraform deal with all this change?
That's where versioning comes in.
Okay, versioning. I have a feeling this is about to get complicated.
It's not as bad as you think.
Yeah.
Think about it this way. Versioning is all about ensuring consistency and avoiding those moments where things break because someone updated something without realizing the consequences.
Like when you update your phone and suddenly your favorite app doesn't work anymore?
Exactly. In Terraform, there are two main things to think about when it comes to versions: provider versions and Terraform's own version.
Okay, let's break that down. Providers first. Remind me, what exactly is a provider in Terraform?
A provider is what lets Terraform talk to a specific platform. So if you're working with AWS, you need the AWS provider.
Right, and each provider has its own version. Got it.
Right. And those versions can introduce new features, bug fixes, sometimes even breaking changes.
Makes sense. So how do we make sure we're using the right provider versions?
In your Terraform configuration, you can use the required providers block to specify exactly which provider versions are allowed.
Oh, okay. So it's like we're telling Terraform, hey, only work with these specific versions of the provider.
You got it. It helps avoid surprises.
That's good. Surprises are usually bad in infrastructure management.
Truth. And this idea of managing versions applies to Terraform itself, too.
Okay, so how do we specify which version of Terraform we want to use?
You can use the required version setting in your config file.
Simple as that.
Yep. You just tell it which versions are acceptable. Like you could say, hey, I need Terraform version 1.1.0 or greater.
Okay, so we've got a way to control the provider versions and the Terraform version itself. But all this talk about versions and dependencies makes me think about one of the classic headaches in software development: circular dependencies.
Oh, yeah, those are fun.
Do we have to worry about those in Terraform too?
Unfortunately, yes. Circular dependencies are like those frustrating roundabouts where you just keep going in circles, never getting anywhere.
I can picture it. But how does this actually happen in Terraform?
Imagine you have two resources. Let's call them A and B.
Okay.
Resource A depends on resource B to be created first, but resource B also depends on resource A.
So it's like, which one comes first, the chicken or the egg?
Exactly. And Terraform is stuck because it needs a clear order of operations.
So what do we do? How do we escape this circular dependency nightmare?
There are a couple ways to tackle this. The most elegant approach is usually to refactor your configuration code.
Okay. What do you mean by refactor?
Sometimes, just by restructuring how you've defined your resources and their relationships, you can break that circular dependency.
Like finding a new route that bypasses the roundabout altogether.
Precisely. But sometimes, refactoring isn't possible, or it might make your code more complicated.
So what's the alternative?
There's a meta-argument you can use called dependency.
Depends on. Okay, what does that do?
It lets you explicitly tell Terraform that one resource needs to be created before another.
Even if the code itself doesn't necessarily show that dependency.
Exactly. You're basically saying, hey, Terraform, make sure A is in place before you even think about creating B.
So it's like giving Terraform a little hint about the order of operations.
A little nudge in the right direction. And that can be enough to break the cycle.
Amazing. It's incredible how Terraform has all these tools to handle the complexities of infrastructure management. So we've talked about outputs, the dangers of drift, that all-important state file, the importance of versioning, and now, even those tricky circular dependencies. Are we ready for the next level?
Absolutely.
What's next on our Terraform journey?
Let's talk about how to manage different environments like development, staging, and production using Terraform Workspaces.
Workspaces. Okay, I've heard that term before, but I'm not entirely sure I understand what they are or why they're important.
Okay, so imagine you're working on a project that has multiple environments.
Right, development, staging, production. Classic.
Exactly. You wouldn't want to accidentally mix up your resources in these environments, right?
Well, definitely not. That sounds like a recipe for disaster.
And that's where Workspaces come in.
Oh, okay, so how do they help?
They allow you to manage separate instances of your state file, each representing a different environment.
So it's like having separate containers almost.
Exactly. It keeps things nice and isolated. You don't want your development environment bleeding into your production environment.
That's a terrifying thought.
And with Workspaces, you don't have to worry about that. You can use the Terraform Workspace command to list existing workspaces, create new ones, or select the workspace you want to work with.
Okay, so if I'm working on a new feature, I can create a development workspace, do all my testing and experimenting there, and then when I'm ready, I can switch to a staging workspace and then eventually to production.
That's the idea. It's a great way to stay organized and reduce the risk of accidentally breaking something in production.
Workspaces sound essential, especially when you're working on a team.
Absolutely. They help prevent conflicts and make sure everyone's working in the correct context.
And speaking of teams and collaboration, let's talk about backend configuration.
It's back-end configuration. Okay, where are we going with this?
Remember how we were talking about the importance of the state file and keeping it safe?
Yeah, it's like Terraform's brain, right?
And
Needs to be protected.
exactly. Now, by default, Terraform stores that state file locally on your computer.
Right.
But in a team environment, this isn't ideal.
You mean having everyone working off their own local copy of the state file?
Exactly. We need a way to centralize it.
So everyone has access to the same up-to-date information.
Right. And we can tell Terraform to store the state file somewhere else.
Like in the cloud.
Exactly. That's what backend configuration is all about.
Okay, so how do we do that?
Well, one popular option is to use AWS S3.
Oh, S3. Yeah, that makes sense. Lots of storage space, easy to manage.
And you can define your backend config in your Terraform code like this.
Okay, we'll see it.
You would add a block that looks like this. Terraform backend S3 bucket, my Terraform state key, global3 terraform.tfstate.region, us west 2.
Right, so we're basically telling Terraform, hey, use this S3 bucket to store the state file.
Exactly. And that way everyone on the team can access.
Makes sense. But what about security? I mean, isn't it risky to store the state file in the cloud? Especially if it contains sensitive information.
That's a great question. We definitely don't want passwords and API keys just floating around in plain text.
No, absolutely not. So how does Terraform handle that?
Well, Terraform has a special attribute for outputs called sensitive true.
Sensitive true. I've seen that before, but I'm not sure I fully understand how it works.
It's pretty straightforward. Let's say you have an output for your database password called DB password. You can define it like this. Terraform.output DB password value all secrets manager secret.example.secret string sensitive true.
So by setting sensitive true, we're essentially telling Terraform to treat this output as a secret and not displayed in plain text.
Exactly. It helps protect sensitive information from being exposed in the command line output or logs.
Okay, that makes sense. But wouldn't it be even better to store those secrets in a dedicated vault?
You mean like a system specifically designed for managing secrets?
Right, like HashiCorp Vault, for example.
Yeah. Vault's a great tool for this. It's got robust security features, access controls, audit trails, all sorts of goodies.
So it's definitely a best practice to use a proper secret vault for storing sensitive information.
Absolutely. Don't just hard code your passwords into your Terraform code.
No, never do that. Use a vault.
All right, so we've got our outputs, including those sensitive ones, but how do we actually get to that information after a successful Terraform run? I mean, it's not like Terraform just spits out a nice formatted report, right?
It does have a way. The Terraform output command is your friend here.
Terraform output. Tell me more.
It's pretty easy to use. If you just run Terraform output without any arguments, it'll show you all the outputs defined in your configuration.
Yeah.
But if you want to see a specific output, you can just include its name as an argument. So, like, if you want the value of your instancy output, you would run Terraform output instancy.
Oh, that's handy. So it's like a little lookup table, and we can use the output command to grab the specific information we need.
Exactly. And remember those sensitive outputs we talked about? The ones marked with sensitive true.
Yeah.
Well, they won't show up in plain text when you use Terraform output. Their values are protected.
That's good to know. Security first. This is great, by the way. This whole deep dive into Terraform is already packed with useful information.
I'm glad you're finding it helpful. It's a lot to cover, but it's all important stuff.
It really is. But there's one thing that's been on my mind as we've been talking about all this. We've talked about collaboration and teams, but what happens when multiple people are trying to make changes to the infrastructure at the same time? It seems like that could lead to all sorts of conflicts and chaos.
You're right. That's a critical aspect of using Terraform in a team environment. It's called concurrency.
Concurrency. Okay. What do we need to know about that?
Well, the main thing is that if multiple people try to modify the state file at the same time, things can get messy. You could end up with data corruption or an inconsistent state.
Yikes. Sounds like we need a way to coordinate our actions.
Exactly. And luckily, Terraform has a built-in mechanism for this. State locking.
State locking. Okay, so it prevents people from stepping on each other's toes.
It's like having a traffic light system for your infrastructure changes. Only one person can have the green light at any given time.
That's a great analogy. So how does this state locking work in practice?
The good news is if you're using a remote backend, like S3 with DynamoDB, state locking is pretty much automatic.
Nice. One less thing to worry about. But what if something goes wrong? What if a lock gets stuck and we need to make an urgent change?
In those rare cases, you might need to use a command called Terraform force unlock.
Terraform force unlock. That sounds a bit dangerous.
It can be. It should really only be used as a last resort in emergency situations.
Like breaking the glass in case of fire.
Exactly. You don't want to use it lightly. And if you're working in a team environment, good communication is key.
Absolutely. Talk to your teammates before you go forcing any locks. But you mentioned something else that might be helpful for teams, something called Terraform Cloud.
Terraform Cloud.
Yeah, what is that and how does it relate to all of this?
So Terraform Cloud is basically a hosted environment for managing all your Terraform stuff, your runs, state files, collaboration, everything.
Sounds pretty comprehensive.
It is, and it comes with a lot of nice features, built-in state locking, role-based access control, even a web interface so you can monitor and manage your infrastructure visually.
It's like taking all those individual pieces we've been talking about and putting them together in a nice integrated package.
Exactly. It's a great solution for teams who are serious about using Terraform.
Okay, cool. We'll have to check that out. But before we head off to the cloud, there's one more topic I want to touch on. It's something called dynamic blocks.
Dynamic blocks. Okay, this sounds intriguing.
They are pretty cool. Basically, dynamic blocks let you programmatically generate nested blocks in your Terraform command.
Wait, programmatically? Like we're writing little programs within our Terraform configuration.
Kind of. It's a way to create multiple instances of a resource without having to repeat yourself a bunch of times.
So instead of copying and pasting code over and over, we can use a dynamic block to create things dynamically.
Exactly. And that can make your code more concise, readable, and easier to maintain.
Definitely. Less repetition is always good. Can you give me an example? Like, when would you use a dynamic block in a real-world scenario?
Sure. Imagine you need to create multiple subnets in your VPC on AWS. Instead of writing out the same code for each subnet, you could use a dynamic block to iterate over a list of subnet configurations.
Oh, that makes sense. So we're basically writing a loop in our Terraform code.
Yep. It's a really powerful technique, and once you understand it, it can open up a lot of new possibilities.
Very cool. I'm already thinking about how I can use dynamic blocks in my own projects.
That's great. I'm glad we could spark some ideas. But we've covered a lot of ground today, from outputs and drift to state management, versioning, circular dependencies, workspaces, backend configuration, and even those fancy dynamic blocks.
It's been quite a journey, and it's amazing how each of these concepts builds on the previous ones.
It really is. It's like putting together a puzzle where all the pieces fit together to create a powerful and coherent system for managing infrastructure.
That's a great way to think about it.
And speaking of putting things together, I'm curious to hear your thoughts on what we've learned so far. Out of all these concepts, which one stands out to you as the most impactful or even surprising?
That's a tough question. There's so much good stuff here. I mean, I'm always impressed by how Terraform handles things like drift.
Yeah, drift. It's one of those things that can sneak up on you if you're not careful.
Right. And it can be a real headache to deal with if you don't have the right tools.
Absolutely. It's easy to imagine scenarios where someone makes a manual change in the cloud console and suddenly things are out of sync.
Or someone uses a different tool to update a resource. It happens all the time.
And then, bam, you've got drift.
And without Terraform, it can be really tough to track down the source of the problem and get things back in sync.
For sure. But Terraform has those great commands like Terraform plan and Terraform apply to help us manage drift effectively.
Exactly. Terraform plan is like our reconnaissance mission. It lets us see what's different between our configuration and what's actually deployed.
And Terraform apply is our action plan to fix things.
It's a powerful combination.
It really is. But none of this would be possible without that crucial ingredient, the Terraform state.
Ah, yes, the state file. It's like the heart of Terraform.
It keeps track of everything, right? What's been built, what configurations have been applied, all the relationships between resources.
It's Terraform's memory. Without it, Terraform would be lost.
It's like those times when you delete a file on your computer and suddenly a program stops working.
Exactly. That file had important information, just like the Terraform state file.
And we can use the Terraform state command to interact with the state file, right?
Right. You could list resources, show details about specific resources, even manipulate resource entries.
Powerful stuff, but also potentially dangerous if we're not careful.
Absolutely. Mishandling the state file can lead to some serious headaches, so security is paramount.
Definitely. Keep it safe, keep it secure. We also talked about versioning, which seems particularly important in a world where everything is constantly changing.
Yeah, versioning is key for maintaining stability and predictability. It's not just about using the latest and greatest. It's about using what's compatible and what works.
So we need to pay attention to both provider versions and the version of Terraform itself.
Right. Providers are how Terraform talks to different platforms like AWS, Azure, Google Cloud, etc.
And each provider has its own version with its own set of features, bug fixes, and sometimes even breaking changes.
And then there's Terraform itself, which also evolves over time.
Right. So how do we manage all these different versions? Do we just have to keep track of everything manually?
Thankfully, no. Terraform gives us some handy tools for specifying which versions we want to use.
Okay, tell me about them. What are these magical tools?
Well, for providers, you can use the required providers block in your configuration file.
So we can say, hey, Terraform, I need this specific version of the AWS provider or this range of versions.
Exactly. And for Terraform itself, you can use the required version setting.
So we can tell Terraform, don't even think about running this code unless you're at least this version or that version.
It's all about controlling the chaos and making sure everything works as expected.
That makes a lot of sense. Now, speaking of things that can cause chaos, we also talked about circular dependencies, which seem like a particularly nasty problem.
Oh, those are definitely fun. It's like trying to untangle a knot that just keeps getting tighter.
And just to recap for our listeners, a circular dependency is when resource A depends on resource B, but resource B also depends on resource A.
Right. It's a classic chicken and egg situation.
And Terraform gets stuck because it can't figure out which resource to create first.
It's like those frustrating traffic circles where you just keep going round and round.
So how do we break free from these circular dependency nightmares? What are our options?
Well, the ideal solution is usually to refactor your code.
Okay, so restructure things, rearrange the relationships between resources, see if we can eliminate that circular dependency altogether.
Exactly. It's like finding a new route that bypasses that traffic circle.
But sometimes refactoring isn't feasible or might lead to more complex code. So what's our backup plan?
In those cases, we can use the depends on meta argument.
Okay, remind me what that does.
It basically lets you explicitly tell Terraform, hey, make sure this resource is created before you even think about creating that other resource.
So it's like giving Terraform a little nudge in the right direction.
Exactly. And that nudge can be enough to break the cycle.
That's pretty cool. It's amazing how Terraform has all these tools to help us handle the complexity of infrastructure as code. From managing drift and the state file to versioning and even circular dependencies, it seems like Terraform has an answer for everything.
It's a pretty powerful tool, that's for sure. And it keeps getting better.
It really does. But out of all these concepts, I'm curious to know which one stood out to you the most. What surprised you, or what are you most excited about using in your own projects?
You know, I think the thing that struck me the most was the idea of workspaces.
Workspaces. Interesting. I know we talked about them earlier, but I'm curious to hear why they resonated with you.
I think it's because, for me, it really highlighted the importance of isolating different environments.
Makes sense. We wouldn't want to accidentally make changes to our production environment when we're just trying to experiment with a new feature in development.
Exactly. And workspaces provide a clean and simple way to do that.
It's like having separate sandboxes for each environment.
Right. And that separation is crucial for safety, organization, and peace of mind.
Definitely. And for me, the concept that really clicked was the idea of back-end configuration.
Backend configuration. Tell me more.
You know how we were talking about the importance of storing the state file securely, especially in a team environment?
Yeah, using a remote backend like S3 so everyone has access to the same up-to-date information.
Exactly. And it just made me realize how important it is to think about where our state file is stored and who has access to it.
It's not just about the code itself. It's about the entire workflow and ecosystem around that code.
That's a great way to put it. It's about thinking holistically about how we manage our infrastructure.
And how we can do it securely and collaboratively.
Couldn't agree more. We also talked about the sensitive true attribute for outputs, which is super helpful for protecting sensitive information like passwords.
Right. And we emphasize the importance of using a dedicated secret vault, like HashiCorp Vault, for managing those secrets.
Vault is a great tool for this. It's got all sorts of features to keep your secrets safe and sound.
And it integrates seamlessly with Terraform. It's a match made in heaven.
Absolutely. But even with all these security measures in place, there's always a risk of something going wrong, especially when you have multiple people working on the same infrastructure.
Which is why state locking is so important. It prevents people from making conflicting changes and potentially corrupting the state file.
It's like that traffic light system we were talking about. Only one person can have the green light at a time.
A perfect analogy.
Yeah.
And it's mostly automatic when you're using a remote backend.
So we don't even have to think about it most of the time. But we do have that Terraform force unlock command for those emergency situations.
Break glass in case of fire.
Exactly. But hopefully we won't ever have to use it. Now, before we wrap up this deep dive, I want to hear your final thoughts.
Okay, what's on your mind?
Now that you've had a chance to really dive into these Terraform concepts, what are you most excited about? What new possibilities are you seeing for managing your own infrastructure?
Well, I have to say, the thing that really excites me is the way Terraform empowers us to think about infrastructure as code.
In what way?
It's not just about automating tasks. It's about treating our infrastructure as a living, breathing system that we can define, manage, and evolve in a controlled and predictable way.
It's like having a blueprint for our infrastructure.
Exactly. And that blueprint is code, which means we can version it, share it, test it, and collaborate on it, just like any other software project.
It's a whole new way of thinking about infrastructure.
It is. And it's incredibly powerful.
I'm curious, what specific aspects of your infrastructure are you most excited to tackle or improve using Terraform?
You know, I've been thinking a lot about how I can use Terraform to better manage my cloud resources.
What kind of resources?
Well, I'm using AWS pretty heavily.
Okay.
I've got a lot of EC2 instances, S3 buckets, RDS databases, you name it.
Sounds like a pretty typical cloud setup.
Yeah, pretty standard stuff.
Yeah.
But I'm realizing that I could be managing all of this much more efficiently and securely with Terraform.
How so?
For starters, I could define all my resources as code, which would make it so much easier to track changes, roll back to previous versions, and collaborate with others.
Definitely. And it would also help you avoid those accidental changes that can lead to drift.
Absolutely. And then there's the whole security aspect. Using a tool like HashiCorp Vault to manage secrets, ensuring that my sensitive information is properly protected.
It's a game changer for sure. And it's not just about making things easier for yourself, it's also about making things more reliable and predictable for your users.
Exactly. When your infrastructure is defined as code, you can be more confident that it's going to behave the way you expect it to.
And that's a huge win, both for you and for the people who rely on your systems.
Couldn't agree more. Terraform is really about bringing order to the chaos of infrastructure management.
It's like having a superpower.
That's a great way to put it.
So where do we go from here? We've covered a lot of ground in this deep dive.
We have. But the journey doesn't end here.
What advice would you give to someone who's just starting out with Terraform?
I would say don't be afraid to experiment. Terraform is a powerful tool, but it's also surprisingly easy to learn. There are tons of resources available online, including tutorials, documentation, and even open source projects that you can use as inspiration.
And the Terraform community is incredibly supportive.
Right. If you get stuck, don't hesitate to reach out for help. There are people out there who have been where you are and are happy to share their knowledge.
That's one of the great things about the open source world. People are always willing to lend a hand.
Absolutely. So my advice is to dive in, get your hands dirty, and don't be afraid to make mistakes. That's how you learn.
Great advice. Well, on that note of exploration and continuous learning, I think it's time to wrap up this deep dive.
It's been a pleasure sharing this journey with you. And remember, the world of Terraform is vast and ever-evolving, so keep exploring, keep learning, and keep building amazing things.
Happy terraforming, everyone.
It really is. And, you know, it's not just about efficiency and security. It's also about consistency and repeatability.
Oh, interesting. Tell me more about that.
When you define your infrastructure as code, you can be sure that it's going to be deployed the same way every time.
Right, no matter who's doing the deploying or where they're deploying it to.
Exactly. And that can be a huge advantage, especially as your infrastructure grows and becomes more complex.
So Terraform isn't just a tool for building infrastructure, it's a tool for managing complexity.
That's a great way to put it. And that's why I think Terraform is such a valuable tool for anyone who's working with cloud infrastructure.
I totally agree. It's been amazing to dive into all these concepts with you today.
It's been fun. I always enjoy talking about Terraform.
Me too. And I'm already thinking about all the ways I can apply these ideas to my own projects.
That's great. I hope this deep dive has given you some inspiration.
It definitely has. But I have to admit, it's also a little overwhelming. There's so much to learn.
I know what you mean. Terraform is a deep and powerful tool, but don't let that intimidate you.
Any advice for someone who's just starting out with Terraform?
Hmm. Let's see. I guess I would say don't try to learn everything at once.
Okay, good advice.
Start with the basics.
Yeah.
Get comfortable with the core concepts.
Outputs, resources, modules.
Right. And then gradually start exploring the more advanced features as you need them.
Don't try to boil the ocean.
Exactly. And remember, the Terraform community is a great resource.
Oh, yeah. There are tons of helpful people out there who are willing to share their knowledge and experience.
Absolutely. So don't be afraid to ask questions, join forums, attend meetups, whatever works for you.
And don't be afraid to experiment.
Experiment.
Yeah, Terraform is a great tool for learning by doing. So spin up some cloud resources, try out different configurations, see what works and what doesn't.
And make some mistakes along the way. That's how we learn.
Couldn't have said it better myself. Well, on that note of experimentation and continuous learning, I think it's time to wrap up this deep dive.
Agreed. It's been a fantastic journey exploring the world of Terraform with you.
It really has, and thank you to all our listeners for joining us today.
We hope you found this deep dive informative and inspiring. And we encourage you to continue exploring, learning, and building amazing things with Terraform.
Happy terraforming, everyone!